we are ready for geometric sequences and series. So last week we talked about, we learned about sequences and series in general, and then we learned about recursive sequences and series, and then we learned about a special type of recursive sequence and series called arithmetic, where future terms are formed by adding the same fixed number to to get the next term, and that common difference was the fixed number that you always add, d. So today we're learning about geometric series and sequences and series, and they're very similar to arithmetic. The difference is, and I have some blanks on your handout that you can fill out, geometric series sequence, and sometimes it's called a geometric progression, so if you hear that word, it means the same thing. It's a sequence in which each term after the blank, and that's what should go in that blank, is the first. Each term after the first is obtained by multiplying a non-zero fixed number to the previous term. So that's what's going to go on your blanks. It's a sequence in which each term after the first is obtained by multiplying a non-zero fixed number, non-zero fixed, to the previous term. Now, the common ratio instead of a common difference is what you get. And so the common ratio R is what I'm going to discuss. It was what your next blanks are, and it says the blank, blank, blank. And so what goes on those three blanks is the non-zero fixed number that is multiplied to obtain the next term in the geometric series. So R is the non-zero fixed number that is multiplied to obtain the next term in a geometric series. Okay, there are some formulas we get to use with geometric sequences and series, just like there were some formulas that we got to use with arithmetic. And so I have them listed on your sheet, and I've written a few of them down. And so we're just going to start going through the problems, and as we need to use these formulas, I'll point them out. So the first one says, find the common ratio R for the geometric sequence. So number one is to find R, and find R, the common ratio. And so part A, they list the numbers 4, 24, 144, and 864. So we want to read the words to see what kind of sequence, if they give us a clue about that. And they did. They said, find the common ratio R for the geometric sequence. They gave us a lot of information. If you hear the words find the common ratio, you know you're dealing with the geometric sequence. If you hear the words geometric sequence, they tell you that, then you know there's a common ratio R. So they told us both of those things, so we are in great shape. We can find it because we know this sequence is built off of, each term is built off of multiplying by the next thing. So just like when we had the common difference, you just pulled out two terms side by side, and you took the one further down the road and you subtracted it from the one in front of it. What we're going to do here is pull out two terms side by side, and we're going to divide the one further down the road by the one in front of it, and that's going to tell us what we're multiplying by. So, for instance, let's pull out 24 and 4. These are beside each other. R is going to be equal to 24 divided by 4, and that is equal to 6. If I were to take 144 and 24 and take 144 divided by 24, I would get 6. I didn't happen to write that, how to find R, but it's on your sheet. I didn't write it down here, but it is for A. Part B, the geometric sequence that they gave us, is negative 135, negative 45, negative 15, negative 5, and so on. All right, so let's pull out two terms side by side. I'm going to take negative 15 and negative 45. R is going to equal to the one further down the road, negative 15, divided by the guy in front of it, negative 45. And negative over a negative makes a positive. And 15 will go into 45 3 times, so 1/3 is my common ratio. Negative 135 times 1/3, or divided by 3, would give me negative 45. Times 1/3 would give me negative 15. Times 1/3 would give me negative 5, and so on. So that's how you do number one. Number two, it says find the first 5 terms for the geometric sequence where, and now they give us a little information. We got to find the first 5 terms, and they tell us that a sub 4 is equal to 7, and a sub 5 is equal to 21. Well, we are really, really in good shape here because they gave us two terms that are side by side. 5 comes after 4. So I'm going to take the one further down the road and divide it by the guy in front of it. And that's going to tell me what my common ratio is. So, plus, they already gave me 4 and 5, so I just got to list a 1, a 2, a 3. Well, if you multiply to get terms in front, you can divide to go backward. So this is 1, this is a sub 5, divided by 3 would give me 7, divided by 3 would give me 7 over 3, divided by 3 would give me 7 over 9, divided by 3 would give me 7 over 27. And so this is the first, second, third, fourth, and fifth term for that one. So you can logic your way through a lot of these without, the formulas will also work if they're appropriate to use if you have the right information. But also you can just use logic sometimes to get your way through some of these. So let's see number 3. It says find a sub 7. All right, we've got to find a sub 7. And also a sub n. These are the two things we have to find. When a sub 1 is 4, they gave us a sub 1. And they gave us r is -2. Well, to find a sub 7, I could use a formula. Let's use a formula. Let's use this one. A sub n is equal to a sub 1 times r to the n minus 1. Oh, let's go ahead and do both of these. A sub n, let's find that. A sub n in general is going to equal to a sub 1, and they gave us that. That's 4 times r. They told us that. -2 raised to the n minus 1. This is the formula for a sub n. So then if I need to find a sub 7, which I do, I'm just going to let n be 7. This is going to equal to 4 times -2 raised to the power of 7 minus 1. So this is 4 times -2 raised to the 6th power. A negative number raised to an even power is going to be positive because there's an even number of negatives. So 2 to the 5th is 32. So 2 to the 6th is going to be 64. So this is 4 times 64, and that is 256. Of course, you can use your calculator to figure that out as well. So that's how you do number 3. Number 4 says find a sub 7. Find a sub 7. And a sub n, same instructions. Find and a sub n for the geometric sequence, and then they just list it. For this geometric sequence 6, -2, 2/3, 2/9, ninths, and so on. Okay, let's see. Oh, this is -2/9. Okay, so we can figure out r pretty easy because they gave us a couple of terms right beside each other. Pull out 2 side by side. Take the one further down the road. -2 divided by the guy in front of it. 6. This is -1/3. This is what r is equal to. Okay, knowing what r is, we can do a lot. If we need to know what a sub 7 is, let's say we've got, this is a1. Let's just take note of that. a1 is 6. This is a 2, a 3, a 4. 5, 6, 7. We could use a formula, or we could just keep multiplying by -1/3. I think I'm going to do that. -2 over 9 times -1/3 results in a positive 2 over 27. So this is 2 over 27. 1, 2, 3, 4, 5. This is going to be the 6th term, and this is going to be the 7th. So if I take 2 over 27, and I multiply that by -1/3, I get -2 over 27 times 3 is 81. -2 over 81. Okay, if I know what the 6th term is, and I do, I just multiply it by the common ratio, which is -1/3. A negative times a negative gives me a positive. 2 in the numerator. And in the denominator, 3 times 81, I think this is 243. So this is a sub 7. That's one approach. The other approach is you could figure out what a sub n is, because we know what r is, and we know what a sub 1 is, and that's all you need to find a sub n, find the formula, and we could let n be 7. That's the other way you could do it. So let's figure out what a sub n is, because that's the second thing we needed to find. A is equal to a sub 1, which we know is 6, times r. What did we decide r was? We said r was negative 1/3. Okay, negative 1/3. Negative 1/3 raised to the n minus 1. This is how we would describe a sub 1. So let's check our work. I said a sub 7 was 2/243. Let's check it by using the formula we just came up with. So if I want to figure out a sub 7, that's equal to 6 times negative 1/3 raised to the 7 minus 1, or 6th power. So this is the number 6. And so negative 1/3 to the 6th power, you can think of this as negative 1 to the 6th power over 3 to the 6th power. That's how I'm going to think of it. Negative 1 to the 6th power is 1. 3 to the 6th power is, let me get my calculator. Where did I leave it? I don't know. It's so far away. Now I might have to just do my multiplication in front of you. 3 to the 4th is 81. So 3 to the 5th would be 243. This is 3 to the 5th. Okay. So 3 to the 6th times another 3. 3 to 9. 3 to 12. 729. 729. Okay. So it's equal to 6 over 729. And if I want to simplify that, I could divide the numerator by 3 and the denominator by 3. 6 divided by 3 is a 2. 729 divided by 3 is 243. So it checks out both ways. Okay, that's number 4. Number 5 says in a geometric sequence, a sub 2 is this and a sub 5 is that. Determine a sub 1 and r. Okay, so now they gave us some other conditions, and we can use formulas or we could use reasoning. Both of these would work, even in this example, because the terms are not that far away. If the terms were really far away, then I would definitely go for the formulas. So we've got choices still. Let's see, number 5 says a sub 2 is negative 3, and a sub 5 is negative 81. Okay, so just like we did with the arithmetic sequences and series, you can plug this information in twice into this formula and solve for r and solve for a sub 1. You get a system of equations, and you can 2 equations, 2 unknowns, you can solve that guy. But these are so close. This is just 2. What comes after 2 is 3, and then 4, and then 5. This is just a little bit down the road from the thing. So I'm going to just think about this. If this is a sub 2, and then there's a sub 3, and then there's a sub 4, and then there's a sub 5, which is negative 81. I had to multiply negative 3 times an r, and I had to multiply this times an r, and then I had to multiply this times an r to get this. So if I take negative 3 times the common ratio 3 times cubed, right, I get the last term, negative 81. Because how did I get this? I multiplied by r, I multiplied that by r, I multiplied that by r, and that gave me negative 81. So this times r gives me this, times r gives me this, times r will give me that. Yeah. So I can just solve for r. I can divide both sides by negative 3 and get that r to the 3rd is 27. I can take the cube root of 27, and I'll get r is equal to 3. So that's the common ratio r. Well, if I know what r is, then I can go backwards. Instead of multiplying by r, I can divide by r. And if I take negative 3 divided by 3, I could get negative 1. And that's a sub 1. So a sub 1 is a negative 1, and r is 3. And you could also plug this in and set up a system of equations like we did last week with the arithmetic sequences. All right, number 6. Let's find a sum. Okay. Now with this one, we have with the arithmetic formulas, we had two sum formulas, and they were both used to find the sum of a fixed number of terms. And they were different depending on which variables you knew. That's what we decided. We have two sum formulas with this one, but these are different formulas. They're not to find the same thing. This sum formula is to find the sum of a fixed number of terms, and this one, interestingly, is to find a sum of an infinite number of terms, which is kind of crazy. But sometimes you can add up an infinite amount of numbers if the conditions are right. If it's a geometric series and the absolute value of the common ratio is less than 1. So that means if R is on this interval between -1 and 1, the absolute value of R has to be less than 1. That means it's got to be 1/2, 1/4, 4/5, 8/9, 13/14, -13/14. As long as it's in between -1 and 1, then we can find the infinite sum to that guy. And it's a geometric sequence. So those are the conditions. So I think I just answered number 10 on this worksheet. So that's the answer to that one. So let's go ahead and do 6. Find the sum of the first 6 terms. So number 6 says find the sum of the first 6 terms. So in other words, find S sub 6 of the geometric sequence 5, 15, 45. Okay, to use this formula, you need to know A sub 1 and R. Okay, A sub 1 is 5, so that's fine. R is easy to find because we have a couple of terms side by side. So take 2 terms, pull them out. 15 divided by 5 is 3. So since we know R, we know A sub 1, we're in business. S sub 6 is equal to A sub 1, 5, times 1 minus R, which is 3, raised to the power of, I have a line drawn right through that. That's supposed to be R to the N. To the N. Okay, what is N? It is 6. All over 1 minus R. 1 minus 3. All right, that's sweet. A sub 1 is 5 and R is 3. So S sub 6 is going to be this guy. So S sub 6 is 5 times 1 minus 3 to the 6. I just did this, didn't I? It's 729, isn't it? It's 729 over 1 minus 3 is -2. So this is equal to 5 times -728 over 2. And let me see where I did this. Oh, I got something different. Let me see what I did wrong here. 1 minus R to the 6th. 1 minus R to the 6th. Oh, I said 3 to the 5th instead of 3 to the 6th. And it should be to the 6th. I think I did it wrong on my sheet. So then 2 can go into this. Oh, now I got to get my calculator for real. 2 into 729 is, I'm getting my calculator.